a series of videos on the subject of chillers. So please remember to check out our other videos and also our website. So firstly, let's look at what a chiller is and what a chiller does. So a chiller is a noisy, large piece of machinery which is used to generate cool water, and that's used to provide air conditioning in buildings. You can see on the animation here the chiller down in the basement. You can also get chillers up on the roof here as well in a slightly different design, but let's not get too involved in that right now. In this video we're going to be looking at what's happening inside this plant item and how it produces the chilled water for the air conditioning, and also how it rejects the heat as well. So in the chiller, the chilled water which is produced in the evaporator, when it leaves, it's leaving, you can see here, it's leaving at about 6 degrees Celsius. And this centrifugal pump here is then pushing that water around the building, where it enters into these AHUs that collect up all the unwanted heat within the building. And this heat is then returned back to the chiller. And it's returning here about 12 degrees, sorry. By the time it leaves the chiller again, it will have given up 6 degrees worth of Celsius of heat, so it's leaving at 6 again. So it leaves at 6, comes back at 12, and this cycle repeats and repeats and repeats. Now the heat that leaves this circuit here is transferred via a refrigerant over to the condenser. Now these two systems are completely isolated from each other. There is just a refrigerant which transfers the heat between these two circuits. So the heat that is picked up in the condenser is then pushed in another circuit up to this pump here, the centrifugal pump, and that is pushed then up into the cooling tower, where the air is forced by a fan inside, and that dissipates and rejects the heat from the building. So this water then returns at a cooler temperature. You can see it's being sent up at 32 degrees Celsius, and it's coming back at 27 degrees Celsius. So this water returns back to the condenser, ready to pick up more heat from the chilled water system and reject the heat from the building. Now, chillers come in all shapes and sizes and thermal ratings, and that really depends on how much heat the building is producing, how much unwanted heat the building is producing. And this unwanted heat comes from sunlight, people, the equipment within the building. Even the chiller itself will generate quite a fair bit of heat as it produces this chilled water. So the system will all be designed to cope with this and to reject that heat and produce enough cooling as it was designed to do. And the chilled water system in this example here, it's a central system, so it's got to a point where having small air conditioning units on each floor is not going to be sufficient to provide the cooling that you need. So it becomes economical to install this large central plant system to produce that chilled water. And you may have more than one chiller. You usually have n+1, so the amount of chillers you need plus one more. If you're in a critical environment, you may even have +2 or +3, depends on what that building needs. But we won't go too much into the detail of that. Let's look at what's happening inside this device here. Okay, let's have a look at an illustration of a chiller to help us understand what's happening inside this plant item and all of its components. So I advise you to grab a piece of paper and a pen and write this down, because you need to know this. There are many designs for a chiller, but these are the 4 main components which will appear in every single one of them. So firstly, let's have a look. We've got the evaporator, Then we have the condenser. Then we have the compressor up on the top there. And down below it, we have the expansion valve. Now, every component of these 4 components is essential to the operation of a chiller. A chiller cannot work without just one of these, any of them. All of them must be present in a chiller for it to work. Now, there are 3 main circuits in a chiller which you also need to know about, so write this down as well. We've got the refrigeration circuit, the refrigeration loop, and this is the refrigerant which passes around each of the 4 components and transfers that heat from the evaporator over to the condenser and back again, a constant loop, getting the heat out of the building and over to the condenser where it can be sent to the cooling towers. The secondary circuit you need to know about is the chilled water loop, and this is the heat from the building that's being collected, sent to the chiller and then back to the building. The third and final circuit that you need to know about is the condenser circuit. This is the heat which is being sent to the cooling towers and coming back to pick up more heat. So these are the 4 components, these are the 3 circuits. You might be wondering about what's happening inside here. So the evaporator, or the chilled water circuit, is the water, if you remember, it's being sent up to the AHUs to collect the unwanted heat from the building, and that's returning at about 12 degrees, and it's coming back into the chiller, passes through the loop, and by the time it leaves again, it needs to be around 6 degrees. Obviously the temperatures can vary a bit, it depends on the setup and design of your chiller, but this is for explanation purposes. So the water that's coming in is held within these tubes, and that keeps the water completely isolated from the refrigerant. The two never mix. The water comes in, passes through the tubes, and then leaves again. It does not leave these tubes. The refrigerant passes through, picks up the heat, and it just transfers that heat through the tube walls there. The refrigerant picks that up and then transfers that round to the compressor. The compressor is located up on the top here, usually always above the chiller, and that is the driving force of the refrigerant. That is pushing, it's creating static pressure here, and it's pushing that refrigerant around the circuit. That refrigerant enters into the condenser. That picks up, that dumps the heat into the third circuit there, the condenser circuit, and that is the water which is being returned from the cooling tower up on the roof, and it's entering into the chiller again through these tubes where it's held within. The water in there does not leave. It enters, passes around these tubes, and then leaves again. The refrigerant comes in and condenses along the tube wall. It does not enter into the water does not leave. It just condenses on there and continues flowing through there, pushed by the static pressure until it hits the expansion valve. The expansion valve is just expanding that refrigerant, giving it a greater ability to pick up heat when it gets into the evaporator there. So these are the 4 main components and the 3 main circuits you need to know about. They will appear in every chiller, all types, sizes and shapes. Alright, so let's apply that knowledge we've just acquired to a real